Hello and welcome to the Kirchoff's current law video tutorial. Here we have a circuit with a bunch of unknown resistors and a bunch of unknown currents, and we are going to determine those currents from just one known current over here. First thing to notice is that there is a node right here, and we have currents entering and currents leaving our node. Whatever the current is that happens to be entering, the total current, we know that it can only leave two ways. Some of it will leave over this resistor, while some leaves through this resistor. The current leaving through this resistor should be twice as much as the current through this one because this has half the resistance, R compared to R. So this current here should be half as much as this current. So half of 2 amps is just 1 amp. So therefore I2 is equal to 1 amp. Next we're going to look at this node up here, and we're going to use Kirchoff's current law. Kirchoff's current law states that all the current entering the node should be equal to all the current leaving the node. The current can't just disappear. So let's look at all the current entering the node. Well, we have I2, that's over here, that's entering the node. And we also have this 2 amps over here also entering the node. Now that should be equal to all the current leaving our node. Well, this is the only source of current leaving the node, so I4. So we already figured out that I2 is 1 amp, so 1 amp plus 2 amps is going to be equal to I4. So therefore I4 is equal to 3 amps. And if you notice, we've actually already solved 2 of the 4 missing currents. So there's I2 and there's I4. Next thing we're going to do is we're going to look at this node right here. So we're going to forget about the voltage source. So we're just talking about the current entering and current leaving. So for this node, I4 is entering, and we have I1 and I3 both leaving the node. So this isn't going to be enough to figure out what I1 and I3 are. We're going to have to use the same type of logic we used at the beginning of the problem. So whatever the current is that enters, this time we know what it is, it's 3 amps. We're going to see more of it leave this way and less of it leave this way because this is more resistant than this way. In fact, we're going to see 3 times as much leave this way as compared to here. So the amount of current passing through I1 is going to be 3 times as much as the amount of current passing through I3. So now what we can do is we can take this and plug it into our top equation here. So I4 is equal to 3I3 plus I3. There we go. And we actually know what I4 is. It's 3 amps. So 3 amps is equal to 3I3 plus another I3. That's 4I3. And we'll just get rid of the unit for right now and bring it back later. So I3 is equal to 3 divided by 4. So 3 divided by 4 is 0.75. So 0.75 amps is the current for I3. So now we can take this and just multiply by 3 to get I1, because it says right here, just multiply by 3. So I1 is equal to that times 3, and that's 2.25 amps. And we'll bold these so that we know these are our answers. So I1 is 2.25 amps, I2 is 1 amp, I3 is 0.75 amps, and I4 is 3 amps. Thank you for watching the Kirchoff's current law video tutorial.